Hi, we are going to talk about 2.3 today, the first and second derivative tests. What I want to do first is I want to do a definition, and then I want to write down the first derivative test for you. And I'm just going to do a bunch of two examples, I guess that's not a bunch. And then we'll do the second derivative test and I'll do some examples. Now I want to do examples for you the way I'm going to expect you to do these in your homework. So please pay attention to my instructions when you do the homework, because I don't want you to follow what the book says, at least for the homework problems. Of course, look at the book while you're, to read it and understand the material. But I'm going to do a little bit of a lecture today. So the first thing we need to talk about is I need to define something. So the definition, the thing I want to define first is this idea of a critical number, a critical value or a critical point. So we'll just call it a critical number of some function f of x is a number a. So this a here, this represents a variable, okay? So it is a number a such that f prime of a is 0. Okay, so why is this a critical value for us, or critical number? The reason this is a critical number is because what we are going to focus on today is we're going to focus on, well, among other things, finding maximums and minimums. And if I have a maximum or a minimum, so if you look, if I have a function that does something like this, if I were to draw the tangent line at this maximum value or this minimum value here, what you notice is that they have horizontal tangents, okay? And what is the slope of a horizontal tangent, you ask? Well, I'll tell you, it is 0, and as I'm sure you know. So the slope of a horizontal line is always 0. So why do I care about critical numbers? Because a maximum or a minimum is going to occur where we have a critical number, okay? All right, so what we need next is this idea of something called the first derivative test. And then I want to do some examples, and I want to show you how I want you to answer questions in your homework. So the section, this book, I just want to tell you why I'm doing this. So this book relies heavily, or this section and the next section, which we're not going to do 2.4, talks a lot about curve sketching. And while curve sketching is interesting and I think it's fun, I mean, who doesn't? Curve sketching isn't really going to be a focus in this course for us. We have calculators, we have computer programs, we have stuff that if we need to see what the curve is, we can actually look at a program to do the curve for us. But it'll be useful for us to actually be able to know some things about the graph just from the straight algebra and not having to have the graph of the function itself. And that's what we're going to focus on. So here's what the first derivative test says. So let's let a be a critical number. I'm going to start getting lazy here. Number of some function f of x. So again, what does that mean? That means that f prime of a is equal to 0. Okay, so here's what the first derivative test tells us. Again, what are we looking at? All we're looking for here is how do we find maximums and minimums. So notice with this function up here, I go positive or increasing. That means my derivative is positive. Then I start going decreasing. That means it's negative. And then I start increasing again. Whoa, that is a crazy graph. So it's positive. So what do you notice? See at this maximum right here? Look at what's happening. My function is increasing, and then it goes to decreasing. And that makes sense then that I would have a max there, right? Because I went increasing and then I turned to decreasing, and so I have a maximum. Here, look at I'm decreasing and then I'm increasing, so I have a minimum. So what this is showing is my derivative, my first derivative goes from positive to negative at a maximum, and from negative to positive at a minimum. And that is exactly what the first derivative test will give us. So, number 1, let's say it this way. F of x then has, we'll say a local or a relative maximum. I'm just going to put max to be lazy here. At x equals a, if f primed changes. Okay, so what is it going to do if we're a maximum? It changes from being positive to negative. Changes from positive to negative at a. Whoops. Okay, from positive to negative at a. So that's what the first derivative test tells me. If I can find my critical numbers, if I can show that my derivative changes from positive to negative at a, I know I have a maximum. 2, likewise, f of x has a minimum. So it has a local minimum at x equals a, at that critical number, if f prime of x changes, now instead of positive to negative, let's look at our minimum up here. What is it changing from? Negative to positive. Has a local min at x equals a if f prime of x changes from negative to positive at a. Now remember, this is just telling you where the minimum or maximum occurs. It's not telling you what the actual value is. Okay, so that's pretty big for the first derivative test. We can determine if we have a max or a min just by knowing what the first derivative does at that value of x. I don't even have to graph it. That's the beauty of the first derivative. So what could happen here? It could go from positive to negative or negative to positive, or there could be no change. So if there's no change, f of x has no local extrema. That just means local max or min, or local extremum. I think it's mum. I don't know. At x equals a if f primed does not change sign. Oh, this is going to get a little closer. Change sign at x. We're good. Okay. So what does that mean? We don't have a local extremum. Let's say if f prime stays positive or if it stays negative, we don't have a local extremum. A really good example of that is x cubed. If you look at x cubed, it goes increase, increase. It kind of goes to 0, and then it keeps increasing. So you'll have a critical number right here at 0. But if you notice, f primed of x is positive, positive, and then positive, positive again. Okay, let's do one. These are really fun to do. I think you're really going to like it. Okay, so first example, what I want us to do, now again, these are my rules because it's my class. So this is how I want you to answer this. So I want you to use the first derivative test. Okay, to find all or any local or relative. I think your book uses relative, but why do I care about what the book says if I'm telling you to do what I say? Oh, sorry, my handwriting today. Find all relative extrema and list the intervals of increasing and decreasing. For the following function. All right, here's our function. F of x equals x cubed minus 3x. Okay, so I need to use the first derivative test to find all the relative extrema of this function and list the intervals of increasing and decreasing. All right, here are your steps. What do we have to have first? Well, if you look at, oh, don't do that. Oh, and I did not want that to happen. Sorry about that. If you look at what our first derivative test here, what is the first thing that we need? Well, the first thing we need, whoops, is this a right here. Okay, I need to find all possible critical values because where are the local maximums and minimums going to occur? They are going to occur at, sorry, that thing keeps messing with me. Darn you, keyboard. Okay, they are going to occur at the critical numbers. So first step, number 1, because I always like steps. Don't you like steps? When I bake, I need steps. Always, always, always. All right, number 1, find all critical numbers or critical values of f of x. And how do we do that? Well, we are just going to take the derivative and set it equal to 0. That is where all of our critical numbers will occur. It's going to be a good time. Keep making my pen. There we go. All right, so first step, let's find f prime of x. So in this case, f prime of x, oh, look at that, the nice power rule. If you are having trouble with the power rule, I need you to tell me. I can't read your minds yet. Probably won't ever be able to. So if you need help, you need to tell me. You got to email me, you got to call me, you got to do something to tell me you need help. All right, so let's set this sucker equal to 0. How do I solve a quadratic that's set equal to 0? I factor this sucker. So I'm going to take the 3 out. This is x squared minus 1 equal to 0. I'm going to keep factoring. I really recommend always factoring this. You can add the 1 over and square root, but then you better be remembering that when you square root, you bring in a plus or a minus. So here are my critical values. 3 can never equal 0. X plus 1 can equal 0. What would that give me then? If x is negative 1, this is 0, so the whole thing's 0. And then if x is 1, this is 0, so the whole thing's 0. So here are my two critical numbers, okay? So the second thing we do then, okay, number 2, test. I want to test f prime of x around those critical numbers, okay? Because what do I want to know? I want to know, let me finish writing this. What do I want to know? I want to know if my derivative changes, if it changes from positive to negative or negative to positive at those critical numbers, because then my first derivative test tells me that I have a maximum or minimum. So here's the trick for this. Now your book does this a little bit differently, and of course my way is better. That's not always true, but I really do like my way. Here's what I'm going to do. I'm going to make, well, pretend that's a vertical line. I'm going to make a nice little number line. And you know, but the only numbers I really care about on this line are negative 1 and 1. Okay? And what I'm going to do is I'm going to test my derivative. Now, what I really recommend when you do this to make it easier is just test each factor of my derivative. Now, I'm not going to worry about the negative 3 because the negative 3 is positive. And remember, what I am testing for the positive or negativeness of f prime of x. So what I'm going to test, I'm going to see, okay, what happens to x plus 1? What happens to x minus 1? And then what would that mean for my derivative? And so you're probably like, what is she talking about? Which I'm going to show you right now. So I want you to give me a number that's less than negative 1. So let's just say negative 2. If I put negative 2 in for x right here, I would get negative 1. All I care about is that it's negative. I don't care if it's negative 1. I don't care if it's negative 472. I don't care. The only thing I care about is that when I put in negative 2, this factor of my derivative is negative. When I put in negative 2 here, what would I get? I would get negative 3. So that factor is negative. So what does that mean for my derivative? Well, if I take a negative times a negative, what do I get? I get a positive. So what do I know about my derivative to the left of negative 1? All the way to the left of negative 1 must be positive. How do I know it doesn't change? So I know that f prime of x is positive from minus infinity to negative 1. I know that. The reason I know that is because f prime of x does not have any other zeros to the left of negative 1. I found all the possible zeros right here. The only way for this sucker to become negative is for it to go through 0. So I have a plus sign. What does that mean? That means that I am increasing. So I like to write a little arrow there saying that I am increasing. Okay, now let me get rid of this guy right here. Now what am I going to do? Now I want to test in between. Okay, I want to test in between negative 1 and 1. I don't want to test at negative 1 and 1. That'd be silly. If you put in negative 1 and 1 into the derivative, you're going to get 0 because these are critical numbers. So let's test in between. Hey, 0 is a great number to put in here. So I'm going to put 0 into here. What's 0 plus 1? That's 1, which would be positive. Put 0 into the x minus 1. 0 minus 1 is negative. Then when I multiply those two factors together to get the derivative, what am I going to get? Positive or negative? I'm going to get a negative. So what do I know about my function? It is decreasing on this interval. Same thing over here with 1. Let's plug in 2. 2 plus 1 is 3. That's positive last time I checked. 2 minus 1 is 1. That's positive also last time I checked. And positive times a positive. That's the value of f primed. That is positive, so that's increasing. Now you don't have to do each factor like this. You could just be plugging this whole thing into 3x squared minus 3. That's fine. Sometimes this just goes a little faster, so you don't have to worry about, oh, what happens when I square it? What happens when I subtract 3? So look at what we have here. So if you notice, what am I doing? I'm changing from positive to negative right here, so my second derivative test tells me this is a max. Here I'm changing from negative to positive, so my first derivative test, I say second derivative test, I'm trying to think of what we're doing next. So my first derivative test tells me that this is a min. And you can kind of see that if you draw the arrows, you can kind of see that this would give me a maximum and this guy would give me a minimum. Okay, what is my actual maximum value, or what is my max? Well, it's going to occur at the point -1, and then I'm going to bring this -1 and I'm going to plug it into the function. If I plug -1 into the function here, so f of -1, that would be a -1 plus 3. So my maximum occurs at the point -1, 2. Where does my minimum occur? At the point 1. And then what is f of 1? Again, plug that into the function now. That'd be 1 minus 3, which is a -2. So my minimum occurs at the point 1, -2. So here is how, so that was testing 3. Our third step, find or determine your max and mins. Okay, I already did that. Okay, find or determine your max or mins. So here's how I want you to write your answer for the max or mins. You want to say we have a local max. What is my local maximum? Of 2. Where does it occur? It occurs at x equals -1. Likewise, oh, I'm running out of room. Let me get rid of a little bit of this. So what am I going to say for my minimum? Oh, even though I'm erasing it. So what am I going to say for my minimum? I'm going to say that I have a local min. What is the local minimum? Remember, the local minimum is the actual function value. If this is a profit function, this spits out, ooh, that'd be sad because I'd have a negative profit, but this spits out the function value is my actual max or min. So I have a local min of -2. Where does this occur? This occurs when x is 1. Okay, this is how I want you to write your answers for this problem. The last thing, we wanted intervals of increasing and decreasing. So what is nice here is I can see that. Here's my increasing, here's my decreasing, here's my increasing. So my increasing interval, what would I say? I'd say -infinity to -1, comma, 1 to infinity. That's where I'm increasing. Where are we decreasing? -1 to 1. And of course, your homework's going to be much nicer than this. This is all jumbled around. If I had a longer page here, I would keep working down from here. And I just want to show you also, let me copy this. I wanted to show you the graph of this. If I can get it to open. Copy image, edit, paste. There we go. Oh, look at that. Okay, so if we look at this, notice here, I can just kind of put this right here. Look at this, says that I'm increasing all the way up until -1. Sure enough, that looks like that's true, right? If you look at this function, up until -1, I'm increasing, then I'm decreasing until 1, then I'm increasing again. Also notice, -1 and 1 makes sense that those are my critical values. If I draw a tangent line here, it would be horizontal. Okay, I hope that makes sense. I think, well, let's see. Let's do one more really quick. Clear this out. And then we'll have to do a part 2 to this lecture because we still have the second derivative. But I want to do one more example for you. I want to make sure that I'm doing enough examples for you. So I want to do the same stuff. Find local max and min and find intervals of increasing and decreasing. I'm being a little lazy here. I'll let you fill that in your notes. For the function 3x to the 4th minus 4x cubed plus 15, or no, plus 5, not 15. And this one's going to be very similar to the last one we did. So let's find the derivative. Remember, our first step is to find the critical values. So we get 12x cubed plus, nope, minus 12x squared. I'm going to set this puppy equal to 0. I'm going to factor. What do they both have in common? A 12 and an x squared. So that would leave me with, did I do that correct? Yep. A 12 and an x squared take that out, and I'm left with x minus 1. So what are my critical numbers for this function? Well, can 12x squared equal 0? Sure, when x is 0. And can x minus 1 equal 0? Sure, when x is 1. And now again, what do? We test. Okay, so I'm going to make a number line. I'm going to test at 0, and I'm going to test at 1. What are the factors I'm going to test? I'm going to test 12x squared. I'm going to test x minus 1, and I'm multiply those together to see what's happening with f primed. Give me a number less than 0. Let's put in -1. Well, this guy's always going to be positive no matter what, because you're squaring every single number. So I might as well just put positive here all the way across, because anytime you square a number, it's positive. So give me a number less than 0. -1 minus 1 is a -2. So that's negative. Positive times a negative. What is that? That's right, that's negative. So what do I know about my function? It's decreasing. Put in a number between 0 and 1. If I put in 1/2, 1/2 minus 1 is also negative. Oh, look at this function. So we know we're also decreasing there. And then, of course, if I put in 2 into x minus 1, that's positive. So I wanted to do this one because I want to show you that here at 1, we get a minimum. But what do we have here at 0? Nothing. Oh, poor 0. No extrema. Okay. So my minimum value is going to be 1 comma, let's find f of 1 really quick. That would be 3 minus 4 plus 5, which last time I checked I think is 4, right? There's my point, okay, and what is my answer then here? F of x has a local minimum of what? 4 at x equals 1. Now, let's talk about increasing and decreasing. Increasing is pretty easy. We go from 1 to infinity for increasing. Here's decreasing. Now, it's going to be a little bit weird. You need to go from minus infinity to 0, comma, 0 to 1. Okay, you have to leave out that 0 because you're neither increasing nor decreasing at 0 because your derivative is 0 there. So no extrema here because we didn't change. This guy is a minimum. All right. That's 22 minutes. I've probably exhausted your attention span. So that's part 1 of this. Now, go get a cup of coffee or get a snack and come back for part 2 when we talk about the second derivative test.